Friends, welcome back to my channel. I have this I/O board, input output board. It is connected in industrial computer. The processor commands this board. It writes some data to some location for that purpose. It uses three types of buses: data bus, address bus and control bus. Control bus is used to read and write. If the processor wants to write something to the peripherals connected outside, it will say write function. When the processor will need to read some data at that time, it will use a read function. So control bus, it will use to select read and write. Either the data is going outside or coming inside. Then the address bus, it is used to select the location. When we say microcomputer, microprocessor, it has some limited slots that are called bits: 16-bit, 8-bit, 32-bit, 64-bit. That are the lines on which processor can communicate. If it have to communicate with many peripherals, many places, at that time different address locations are selected. For that purpose, this address decoder 74138 is used to decode the address, which port is to be selected. All the lines in parallel, for example this one, this one, this one, all the ICs in parallel. Just only which IC is enabled, that will send the data or that will receive the data. So I have problem in this board. Let's check the most common failure component which are connected in this board, that are the transceivers. When we are troubleshooting, most of the time these transceivers make problem. It is using 74LS245. All the ICs are connected on the base. Today I will demonstrate how we can test this transceiver. Transceiver, basically it is a line driver. When the processor is working, processor don't have too much current that it can communicate with many devices, because every component it has sync current. For that purpose, these drivers, we can say these are working as a booster, signal booster. To test this IC, I will use these LEDs to display the signal. When we have many ICs in the same line, if one IC is bad, all the data will be interrupted. If you check here, it have 8 lines. Pin number 2, 3, 4, 5, 6, 7, 8, 9. These are the data lines, data ports. And it is also data port pin number 18 to pin number 11. It is called side A, it is called side B. When we say inverter, buffer, it is a buffer, it is a driver. But the condition here that we have two control pins here, pin number 1 and pin number 19. Pin number 19, that is enable signal, that is called output enable, or we can say it is chip enable signal. And this one pin is direction pin. If it will high, it will give data from one side to the second side, and when it will low, it will receive data from this side to this side. Here is truth table, function table. Output enable, that is pin number 19, and the direction, that is pin number 1. Here is combination of these two pins, which I discussed here, that address pins, address decoder LS138, it uses this function. It receives a 3-bit data or 4-bit data from the microcontroller, from the computer, and it will decode and it will select the function of this IC. If output pin is low, direction pin, that is pin number 1, is low, data transmitted from bus B to bus A. Bus B is this side. The data will be transmitted from bus B to bus A. And when output enable pin number 19 is low and pin number 1 is high, the direction pin, data transmitted bus A to bus B. The data will be transmitted from this direction to this direction. And if output enable pin is high, at that time it will go to in isolated mode. It will make a barrier between these two pins, so it will go in high impedance state, that is called tri-state. It will not high, it will not low, so it will not draw any sync current from the processor, or it will not make load for any output device. If we see its logic diagram, this is pin A. We will see one module, port A, pin number 2. It have a buffer here that is called driver. When this pin is enabled at that time, it will give output to port B from here to here. And when this will enabled, this is called read and write function. At that time, pin 18 will input and pin 2 will output. So the role of the pins will be reversible by using these two commands, direction and output enable. For that purpose, I am using LEDs. How we will use LEDs? We will use 330 ohm resistor at each output and one LED grounded. This will be connected at output. We have 8 outputs and 8 LEDs I am connecting here. This side is connected to ground. For input, I will connect one resistor, pull-up resistor, 10 kilo ohm, and we will connect to input pin, and we will connect a push button. When we will push it, it will give low signal. So this is input and this is output. The same way all the anodes are connected with resistors, and this side is connected to the low side. And I will use this push button. I will apply 5 volt to pin number 20, and we will connect ground to pin number 10. I will connect pin number 19, that is output enable pin. When we will connect pin number 19 to low, that is ground pin, and direction pin to low, B will input and A will output. Pin number 1 to the ground, and we will connect the ground side. Okay, let me connect ground here. That is easy. That's best to give rail here, and I will connect. I connected ground pin, pin number 10, and I will connect ground to all LEDs. LEDs grounded, and I will connect ground to this push button second side. This time pin number 19 is low, 1 is low. Data will be connected from B side, that is our higher side pins 11, 12, 13. So this is input, now this is output. We will connect output here. All the LEDs we will connect here. This is the first one, we will connect to pin number 9. The second, 8. I will connect all the pins. Now I completed the connections. I connected positive supply to the pin number 20, ground to pin number 10. I connected output enable pin to the ground and pin number 1 to the ground. So when we connected these two pins to low, the data will transfer from B side to A side. So this is now output side. I connected all the LEDs from pin number 2 to pin number 9. These are 8 outputs, and we will apply inputs here. This time I will apply power. We can see now all the outputs are high, because when we open any input of logic gate, that is floating input, that is not connected to low, it will be considered as high. Now we will connect one by one and we will check the response of the IC. Now I will connect the first pin, that is 11 number pin, to the push button, and I will press push button. So our first LED is now responding. The second, third, fourth, fifth, sixth, 7, 8. All channels are now responding. So we can say the data transfer from this side to this side is working good. All these internal logic drivers, line drivers are good. Now we will verify this side. To verify this side, what we will do, we need to change direction pin to high, which is direction pin, pin number 1. Just only one difference. Now pin number 1, that will connect it to high voltage, that is 5 volts, logic high. When we will change this pin, now all our output pins will change. In our last condition, pin number 11 to pin number 18 were input pins, and pin number 2 to 9 were output. Now when we change this pin, pin 1 to high, this time our output direction is changed. Now this is output and this will input. Let's connect all these LEDs to output side. Now the role of this IC is changed. Now this is our input side. I will power on again. Now we can see all the LEDs are now in output condition. Now I will connect to the first pin, pin number 9 here. It is changing now. I will move input to pin number 8. It is working good. If any pin will stuck in that condition, that IC, that port will not work. Using this technique, we can test the IC very simply. When we will push this button, we are giving a low signal. If the push button is off, at that time it is high signal. Now if we can say pin number 19, if it is high, pin number 19, this one is high. If you connect it to high side, what will happen now? Now it is in off condition. We connected pin number 19 to high, IC will go in off state. It will not receive any input or it will not give any output. If we apply any input, high, low, to any side, it will work as that it is not present in the circuit totally. We can enable this IC by connecting it to the ground. Now this IC is enabled. Just only the direction pin will change input to output, output to input. If it is low, direction pin is low, data will flow from B side to A side. If it is high, data will flow from A side to B side. A side is pin number 2 to pin number 9, and pin number 11 to pin number 18, that is B side. I hope so you enjoyed this video. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.